Next on the agenda is Paul Pilarski, the bridge construction and scoping engineer from the Minnesota DOT, chloride testing and hydro demolition.
So first I'll talk about this National Chloride Working Group. So I got involved in this last year or a year and a half ago, but it started with Travis Kinney in Oregon. Came up as a technical topic in the Western Bridge Preservation Partnership monthly conference calls that they said there seemed like there was a need out there to do more chloride testing to enable better programming and understanding of their deck condition, but there's a lot of variation in terms of how it was being performed. They were all over the map. And they thought, let's develop a guidance document that would help people be consistent in our approach and inform everybody. So Travis organized a group to develop a National Bridge Preservation Partnership guide on bridge deck chloride sampling. And included in that, we developed some specifications and a contract template so you could just fill in your agency and tweak it a little to your needs. So the working group owners, this is representation from the owner perspective. Andrew from Oregon DOT, Travis led the group, and then myself, and we've got good representation from California, Utah, and Virginia. And then from the industry, I'm pleasantly surprised that we've had great participation there, lending their thoughts on what makes a good chloride sampling strategy, what's a statistically significant sample, all that. So we've all kind of come together with monthly conference calls and advanced the document. So chapter 1, what you're going to get for a product is an overview of chloride deterioration and discussion on preservation versus rehabilitation. Chapter 2 is going to be how you do it at the network level, how you select a sample set of bridges and which ones might want to rise to the top in terms of the bridges you want to sample. We'll be looking at condition-based sampling criteria such as deck condition, environmental factors, or maintenance project history influences. Importance-based sampling such as the ADT and bridge significance, and also structural features such as a box girder or something that you rely on structurally in that deck more than others. And then from the program management side, there's going to be how you manage the sample data, how you take into account the timestamp with that chloride and where you go with it for future. So chapter 3 is project level sampling. If you know of a certain project, what would you do out there to scope it? It's covering the methods of sampling, the number of samples, where to take them, and what sort of field testing versus laboratory testing you might do. And there is mention of sulfate contents and the influence of that, and other factors that might impact your sampling accuracy. Chapter 4 is intended to do modeling test results, how to process this data, and it's kind of minimalized because our documents started to get too long. We're covering too much scope, so the modeling section is going to be a little more limited, and that might be relegated to future work. The appendices talk about some sample projects that different agencies have offered up of how they've used this data. And then Appendix B is a boilerplate of the work. So we're about 99% complete. It's always at 99%, and the 1% takes the longest. And right now it's in final QC. It'll be distributed to the 4 regional partnership for review and approval in a 2-month time frame, and then published through the TSP2 website. Future work is covering additional factors that might affect deck deterioration, developing this disbursement presentation that people can bring to meetings and talk about the document more than what I'm doing here, and also what to do with the results of your chloride profiles. I think there's a lot of discrepancy in how people use the results and what it means to them. Any questions on that working group? I'm going to move on to the next one, and this is not really a working group. It was a domestic scan, and I got voluntold to be on this scan, and I was glad I did. It was really interesting. You know how that works. So the scan is NCHRP 20-68, domestic scan 18-01. Successful approaches for the use of hydrodemolition for partial depth removal of bridge decks. Findings, conclusions, recommendations. So part of this is we've got some agencies using more of it than others, and Cheryl, I forget her name, but Utah was leading this effort as they were getting into more hydrodemo, and they said, let's see what other states are experiencing with this, what the best practice is, and why are we doing this alone? Let's see what more mature states are doing and where we can learn, and develop a national guidance document. So it was requested by the AASHTO Committee on Construction, or SOC, and it was funded through NCHRP. And the guidance to our scan team was document case studies. We want to know what we've done, how it's worked out, and then look at both current hydrodemolition and ones that have been out there for a while in the world and see how they're performing, if they're any better than traditional practice of milling. We're also going to, we have kind of studied the hydrodemolition process and the long-term performance, kind of a qualitative and inspection report kind of perspective, and then get perspectives from agencies, contractors, and consultants on where the benefits are and the costs and all that good stuff. So a lot of areas here that I won't go into in detail, but there's a lot of kinks to work out when you say, I'm going to do hydro. You got patch removal, you got water permitting, the wastewater, what you deal with that, or how you deal with that. If you got section loss and your reinforcement, how do you chase that out? And during our scan meeting, we spent a week looking at various states' experiences with hydro, and it ranged the spectrum from it was very successful, we have 30 years and it's going strong, to we ended up with a redeck out of a hydro demo. So it's kind of eye-opening, and we just want people not to try it on their own without learning from others' experiences. So we hope to collect all those case studies and put them out there, or at least get some of the lessons learned from them into our document. The scan team is Cheryl Simmons from Utah. She really led this effort. We've had Louisiana representation, Jenny Fu, John Belcher from Michigan, myself, Baruz Rad from Maryland District of Columbia, Dwayne Wilson, Washington State, Hannah Chang from New Jersey, and Romeo Garcia, our FHWA construction management team rep. And then Brent Ferris from Iowa State is putting this all together. So just a map of who participated. The green states are members that are participating at a higher level, and the orange states are people that brought experiences to the presentations. So we've got some very basic findings to distribute at this point, that hydrodemolition has been successfully used in multiple states for many years. And there are two classes. You got shallow removal or deep removal, just to keep it simple in terms of how we treat the deck. And then both classes can be effective, and the selection is principally one of economics. Do you want to go deeper or shallower? And there's some cost benefit differences between them. We also found there's wide-ranging practice in what repair material you put back and what overlays are used out there. Multiple states have used this for many, many years, over 20 years in some cases, and and some states are doing it as their standard. So when it comes to implementation, you do need experienced inspection staff for success, and the document will talk about what you're looking for when you're inspecting. And then the environmental permitting process and job controls can vary from state to state, and we hope to cover what we've learned from different states' experiences. Again, in hydrodemolition, it's a very effective tool in the toolbox for bridge preservation, and we determined that the best time is likely between 5 and 20% deterioration in the deck. And the primary reason is to give a deck that's receptive to an overlay, free of micro cracks, and has notable roughness. Long-term performance is very dependent on the curing of the replacement material, and it can be most cost-effective when you're milling off and then doing the subsequent removals with the hydrodemo. Don't try to do it right from the surface with hydro. And again, this is kind of a repeat, but do it with a holistic deck preservation program. Monitor the deck condition and make sure we're doing it at the right time to achieve a deck that is perpetual and achieve multiple lives. And then make sure to tap the resources. We hope to publish the states that are contributed to this so that we can reach out to each other and learn. Next steps, we're going to document in a concise but complete report, and we're going to promote it via technical webinars and distribute to the various AASHTO committees for further adaptation and usage of hydrodemolition. Here's the link to the report, and we hope to send out a note to our groups here for when it's actually published. Any questions?
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.